Hey everybody, we are getting into calculations with acids and bases now for Unit 10.3. And what we're going to kind of start off with are your basic pH calculations, because pH is honestly the biggest thing that you're going to need to determine when we're dealing with an acid or a base. And the calculations do get a little bit more complicated, but you kind of need to know these basic formulas and calculations before you can get, any further. So we got to walk before we can run. And so that's what we're going to focus on. You need to make sure that with this, you have a calculator that can do a logarithm calculation, and not a natural log, but an actual base 10 logarithm. Because you will need that to do your pH calculation. So if you don't have that, that's going to be your first order of business, and then we should be good to go. So when we talk about pH, pH represents P stands for power and H stands for hydrogen. So when we talk about the pH, technically it's the power of the hydrogen in a solution. And really what that means is it is a reflection of how much H plus is in that particular solution. So we've talked about how acids bump up the concentration of H plus and bases bump up the concentration of OH minus. And if you think about our equation for the autoionization of water, normally in water, the concentration of H plus and OH minus is 1 times 10 to the negative 7th molar for each of them, and it gives us our Kw value of 1 times 10 to the negative 14th. Here's the deal. In an acid, what an acid does is it drives up that H3O plus concentration right here. That goes up, and because it is an equilibrium constant, our OH minus concentration has to go down as a result because it's an equilibrium. So if we think about one concentration going up, the other concentration has to go down because they always have to equal 1 times 10 to the negative 14th, kind of like we talked about in our last video. So what we're going to do is we're going to keep those things in mind as we go through and do our pH calculations. When we talk about pH, to calculate a pH value, you need the hydrogen or hydronium ion concentration, the H plus or the H3O plus. And to get that calculation, you're going to take the negative log of that molarity. So negative log of H plus gives you your pH, or H3O plus if you're talking about your hydronium concentration. It is a logarithmic calculation, and the negative value that you have there, that negative sign, takes a power that is negative, usually in our concentration value, and then turns that into a positive whole number. We'll get into the pH scale a little bit, but what you need to know is because pH is calculated using logs, it results in changes that aren't necessarily to be expected. So if I would go from, let's say, a pH of 3 to a pH of 6. I double my pH, okay? That does not mean that I double the concentration of something that's in there. What that actually means is there's a change of a factor of 10 for every pH unit that I'm dealing with. So if I go from a pH of 3 to a pH of 6, there is a change in concentration of 10 when I go from 3 to 4, 10 when I go from 4 to 5, and 10 when I go from 5 to 6. So there's actually a concentration change that's a factor of 10 to the third power, or 1,000 times concentration change. And that's what's a little bit different about your pH scale. So again, if I have an H plus concentration, that's 1 times 10 to the negative 3rd molar in hydrogen ions, my pH is going to be a 3. If I have a concentration that is 1 times 10 to the negative 4th, so 10 times less concentrated, I'm going to have a pH of 4. And every whole number unit that you see on the pH scale matches up with 1 times 10 to the negative whatever that power is. So if you think about our pH scale as being neutral, we tend to think about water as being neutral. Water has a pH of 7. And that's because under normal circumstances, when we don't have any acid or base added to it, water naturally settles out at a concentration of in the neighborhood of 1 times 10 to the negative 7th. So if I take the negative log of that, that gives me a pH of 7. Anything that's higher in concentration than 1 times 10 to the negative 7th molar hits acidic territory. And on this pH scale, it goes to 0, but you should know that you can have negative pHs. It's totally normal. So if I have a concentration of 1 times 10 to the negative 6th, that is going to be a pH of 6. 1 times 10 to the negative 5th is 5, and so on and so forth. So as I move every pH unit away from 7, I get 10 times more concentrated. So from 4 to 5, my H plus concentration is 10 times more. From 4 to 3, it's another 10 times more. And if I go the other direction, it gets less. So it's 1 times 10 to the negative 3rd molar at a pH of 3, and 1 times 10 to the negative 4th molar at a pH of 4. So that is our acidic side. Now on the opposite side of things is our basic, or you'll hear it called alkaline sometimes, side. And in this case, it's 1 times 10 to the negative 8th molar, 1 times 10 to the negative 9th molar, and on and on and on. Understand that your concentrations can possibly lead you to having pHs that are higher than 14 as well. So if you see a pH that's above 14, like 14 something or 15, that's totally normal and not unheard of. We usually put on our pH scale an ends of 0 to 14 because most of the substances that you're going to encounter are going to be in that range of your pHs. But you have to understand that this is a value here that's determined based on that concentration. So if I have a solution that's got a concentration somewhere between 1 times 10 to the negative 6th and 1 times 10 to the negative 7th, I'll get a pH that's between 6 and 7. And you just have to kind of estimate that. And we'll work on that in class together. Okay. So on our pH scale, we have all sorts of different things. Like we said, normally water is going to be a pH of 7 if it's perfectly neutral. That's hard to find, but it can happen. Foods tend to be more on the acidic side, and on the extreme side would be like the acid that you see in a battery. And on the opposite side, you tend to see more cleaners and things like that on the basic side of your pH scale. You're probably not going to want to, eat soap or bleach or drink cleaner, bad life choices there. So those are more cleaning products on the basic side. And then on the acidic side, you see more foods and things like that. Okay. Now, there is something else called a pOH. And technically, if you take the P of anything, that sounds really inappropriate, P whatever, or the negative log of whatever, you can calculate the P of that calculation. So what I mean by that is there's this value called the pOH, okay? pOH is the negative log of the hydroxide concentration in solution. So if you know what the hydroxide concentration is in your solution, you could take the negative log of that and find the pOH. And you'll see in the next slide, but our pH value and our pOH value have to add up to 14. And that's because of that KW relationship. H plus and OH minus have to equal 1 times 10 to the negative 14th. So if we have a low number for our pH, we got to have a high number for our pOH and vice versa. So if we look at our scale here, if I have something that has a pH of 0, it has a pOH of 14. And if I have something that has a pH of 14 and is very basic, I have a pOH of 0. So they kind of work on opposites of each other. If we know our pH, you can take 14 and subtract your pH to get your pOH. So there are a bunch of equations that you need to know to be able to kind of start with pH calculations. And our first two here are the ones I've talked about already. The pH is negative log of H plus concentration, and pOH is the negative log of the OH minus concentration. So that's going to get you the P value. We will eventually talk about pKa's and all that jazz, but not today. If you know your pH or your pOH value and you want to find the concentration of the acid ion or the hydroxide ion, you need to take 10 to the negative pH. And essentially that's going to undo your logarithm and give you your original concentration that you're going to start with. Another one you got to keep in your back pocket is the fact that pH and pOH give you 14. They add up to 14. And then this one here is that relationship to the KW that we talked about, that the concentration of H3O plus times OH minus has to equal 1 times 10 to the negative 14th. And the great thing about this is that all of these equations provide you with a number of ways to solve your answers. So we are going to go through some examples together and we will see how things go. So we'll start off here and I'll get onto my DocCam. But I'm going to ask you to calculate the pOH, H plus, and OH minus concentration for a solution with a pH of 7.4 at 25 degrees Celsius. Alrighty. So we'll get that squared away here. And then we'll take a look at it. So given the information that we have in our problem here, they tell us that the pH is 7.4 already. So we know our equations, and I would really recommend writing those equations down somewhere because you're going to need them. I tend to think if I know my pH, the easiest calculation to do is going to be my pOH calculation. And I'm going to change my setting here quick. I always forget to do this. All right. So if I know my pH is 7.4, I know that my pOH has to add up to 14 with my pH. So if I want to find my pOH, what I'm going to do is I'm going to take 14 minus that 7.40 to get my pOH value, which is going to be 6.60. We typically report pHs in 2 decimal places. I don't think I've ever seen it reported any other way, so I would do 2 decimal places here. All right. So that's the easiest way to find your pOH. Now, if I want to find my H plus concentration, and I already know what my pH is, what I can do is I can take 10 to the negative pH, which is 7.40, and put that into my calculator. You cannot leave it like this. They will not give you credit for that on the exam. So I need a number that makes sense to me. I have no idea what 10 to the negative 7.4 is if I'm looking at that answer, but I do know if I report that in a molarity. So if I plug this into my calculator, and typically I'll do 10 with a little caret to the negative 7.4, I get a value of 3.98 times 10 to the negative 8th molar. Okay, so this here is a number I understand. This is a number I don't understand. And if we think about the value here, if our pH is above 7, it's going to be basic. So this solution here is basic, but, you know, not super basic. All right. This is the one part that's kind of nice. To find our OH minus concentration, there are 2 ways to do that. So one way would be to use the pOH and kind of undo the pOH, similar to our pH value. And I like that. I think that's the easiest. So if I want to find my OH minus concentration and I know my pOH, I'm going to take 10 to the negative 6.6, put that into my calculator, and I'm going to get 2.5 times 10 to the negative 7th molar. And I believe that ends up being 2.50 if we do the rounding. Okay, that's one way. The other way we could solve for this if we wanted to is that we know concentration of OH minus times concentration of H plus has to equal 1 times 10 to the negative 14th. So if I knew my H plus concentration first, then I could solve for my OH minus. So if I have OH minus, it's equal to 1 times 10 to the negative 14th divided by that 3.98 times 10 to the negative 8th molar. And I'll get that same answer of 2.5 times 10 to the negative 7th molar. So it works kind of either way when you're solving for those concentrations. So just kind of keep those in your back pocket. I'm not going to flip back to the original screen, but here is another example problem for us to kind of work through. So in this one, we're going to calculate the pH, pOH, and H plus and OH minus concentration for a 2 times 10 to the negative 2nd molar HCl solution. All right, so we're given a specific solution here, and what we should note is that HCl is one of our strong acids that we discussed previously. And we know that our acids, if they're strong, dissociate 100%. So if you are looking and it's asking you to calculate the pH of something that's strong, all you have to do is look at the concentration of your acid, and that is my concentration of my H plus as well. So if I know that this is a strong acid, this is going to be the concentration of my H plus. So if I want to do that, let's start. Concentration of H plus, got that one done. Congrats. 2 times 10 to the negative 2nd molar. So we know that. If we know our concentration of our H plus, we can find our pH value. So I've got my pH equaling the negative log of my H plus concentration, 2 times 10 to the negative 2nd molar, and that equals 1.7. Okay, so if I know my H plus concentration, I can find my pH pretty easily. Now, stop and think about how you're going to find your POH or your OH minus concentration, because we got two options for it. I'll tell you what I think is my easier option, but it's up to you. If it's me, I'm going to find my POH next, because I think that math is easier. So I'm going to do POH and figure that out. And it's 14 minus my pH, which is 1.7. And when I do that subtraction, I get a POH of 12.3. Okay. Remember, these have to add up to 14. And so everything is right in the world. And then lastly, I'm going to get my concentration of OH minus by taking 10 to the negative 12.3. And I get a value of 5 times 10 to the negative 13th molar. Okay, so that is one way that you could solve this. If you felt so compelled, though, you could use your concentration of H plus and take 1 times 10 to the negative 14th and divide it by 2 times 10 to the negative second, and then get 5 times 10 to the negative 13th molar for my concentration of my OH minus, okay? And then you could find your POH from there. So there are a number of options as you're kind of going through. So just kind of keep that in mind as you are doing these calculations, that a lot of times there are multiple ways to kind of get out of the problem that you have. The other thing to remember is that if this concentration is high, then the OH minus concentration needs to be low. And they always need to multiply together to be 1 times 10 to the negative 14th. And if you think about adding the powers here, we've got a negative 2 and a negative 13. So you're like, oh, that's a negative 15. But 2 times 5 gives you 10. So then that takes away one of those powers and you get to the negative 14th. All right, one more just for good measure. I feel like it's useful for us to talk about a base in example 3 here. So we're going to do the same process, but this time we're going to be doing this for a calcium hydroxide solution instead of an acid. And if you remember, calcium hydroxide here is a strong base. So being a strong base, it is going to dissociate 100%. And if we think about how calcium hydroxide is going to break apart here, calcium hydroxide is going to break apart into Ca plus 2 and 2 OH minuses. Our strong bases break apart like this. It's not like our strong acid H2SO4 where we only lose one hydrogen. It's a little bit different. All right. The consequence of this 2 OH minus means that this is the concentration of my calcium hydroxide, but the concentration of my OH minus is 0.008 molar because I get 2 hydroxides for every calcium hydroxide that's dissolved. Okay, so here's what I want you to do. We know that this is our concentration of our OH minus. We got that figured out. What I'd like you to do is pause the video, see if you can figure these things out, and then we will check them over, okay? So pause the video, get out your calculator, and then give them a try. Like for real, go do it. Okay, so we want to get all of our calculations. Since I know my concentration of OH minus is 0.008, I got that one taken care of. Hooray for me. But I've got this, so I think probably the easiest one to solve for is going to be POH. So my POH is going to be the negative log of 0.008. Okay, so negative log of 0.008 gives me 8 times 10 to the, oops, that doesn't seem right. Hold on. It gives me 2.1. I was going to say that doesn't make any sense. So it's 2.1. It's a low POH, but if you think about it, that means I'm going to have a high pH, which is what should happen if I have a basic solution. So my POH is 2.1. If I have my POH, I can solve for my pH by taking 14 minus 2.1, and that gives me a pH of 11.90. Okay. Then I want to find my concentration of H plus, and there are 2 ways to do that. You can use this concentration here to find it, or you could use your pH to find it as well. In this case, I'm going to use my pH because I just really think it's easier. So I'm going to take 10 to the negative 11.9. Remember, this needs to be put into your calculator and given an answer, and it should be 1.25 times 10 to the negative 12 molar. So this is a basic solution. We've got a pH that's above 7, a pretty low H plus concentration, and a high OH minus concentration. So these are kind of the fundamental pieces, these equations, of what we will use when we get into calculating buffers and weak acids and weak bases. If you have any questions, please make sure you get that cleared up. Otherwise, good luck on your